Hello everyone. Note down Archimedes Upthrust. Upthrust or buoyancy force. We have an object and in blue you can see the liquid. This is the height of the liquid level in the beaker, and this object is, you can say, floating in this liquid right now. Density of the liquid is rho, and this much is h. Height of the object, which is inside or is submerged, is h. Mass of the object is m. On this object, force is coming from three sides. If you draw the free body diagram, of this object, then force is coming from this side. Force is coming from this side, and force is coming from this side. And everybody knows that there will be a downward force of mg also. Let's show it with blue color. All the forces which you see in black, they are coming from the liquid only. On this object, these are the forces shown in black. They are coming from the liquid. You all can see that this will be cancelled by this, and therefore only force which is effectively is present on the body is this. What is the direction? Up. What is the force? Normal reaction force. In pressure, the force which we take is always what? Normal reaction force. Normal reaction force always acts towards the body. This is the force. This force is Fu, U for upthrust, and we need to find this. Now, if you need force, you should have the idea of pressure. This is H. At a depth of h, in a liquid of density rho, you know that pressure at this place, pressure at the bottom of the block, right here, it will be H rho G. Not at the base of the beaker, at the base of the floating object. What is the pressure? H rho G. Depth is H. In static condition, in a situation where you have the equilibrium, at a given horizontal level, everywhere pressure is same, and we have already proved that pressure in all directions is what same. So this block is being pushed up by the pressure. What is force? Pressure multiplied by area. What is A? Area of the base of this floating object. For the time being, if I say it's a cube or a cuboid, then let's say this is the body, then base, this base is what is A, and this is being pushed up by a force of Fu. So what is Fu? Pressure multiplied by area, area of the base. This gives us H rho G multiplied by A. Multiplied by base area. Let's group H and this A together. It becomes HA rho G look at this part, HA. What is HA? HA is volume of object which is submerged inside the liquid. Base is A, height of the object which is inside the liquid is H. So what is HA? HA is volume submerged multiplied by density into G. This is one way of remembering Archimedes upthrust. What is upthrust force? Volume of object which is submerged inside the liquid multiplied by density of liquid into G. Now, we'll write all these statements later on, but look at this part. Can I say volume submerged into density is mass? And the answer will be no. Why not? This volume submerged is volume of the object, whereas rho is density of the liquid. But I can say this, volume submerged is also same as volume of displaced liquid. अगर आपने किसी चीज को सबमर्ज किया, जितना आप उसको लिक्विड में सबमर्ज करोगे उतना ही लिक्विड क्या होने वाला है, डिस्प्लेस. This is volume of submerged object. If you wish you can write like this, volume of submerged object, which is same as volume of displaced liquid multiplied by density of liquid into G. अब फायदा क्या हुआ? This is volume of the liquid and this is density of that liquid, which means you got what? Mass of displaced liquid mass of displaced liquid into G, which is what weight of the displaced liquid. So what is upthrust on an object? What is buoyancy force on an object? Weight of the displaced liquid. Or we can say this, volume of submerged object multiplied by density of liquid into G. दोनों तरह से अपने काम आएगा, but let's complete the whole analysis. If you say what Archimedes found, that if an object is floating, object then is in equilibrium and therefore Fu is balancing what mg. Fu is balancing what mg. When is this equation true? When object is floating. For floating condition. For floating object, its weight should be balanced by the upthrust. Mg is equal to what? Fu. What is Fu? Weight of displaced liquid. Remember, this is W displaced in this weight of displaced liquid. What Archimedes found, that if an object is floating, then its weight, what is mg? Weight of the object is equal to what? Weight of displaced liquid. This is the Archimedes statement which we have found using what? Concept of P equals to H rho G. We'll write down all these statements, note down everything, and if you understand all these transformations, then write down yours in the comment box. Now write down these statements. Upthrust acting on an object. Upthrust acting on an object is equal to volume of object submerged inside the liquid. Volume of object submerged inside the liquid. Write down in the form of a statement. Volume of object submerged inside the liquid multiplied by density of liquid multiplied by G. And when we are using this formula, that volume of object submerged inside the liquid into density of liquid into G, we don't have to worry about whether object is floating or not. Mention this also inside a bracket. Object may or may not float, but this formula is always correct. Object may or may not float, even if this object sinks down. If it sinks down, even then you can use this formula. If it sinks down completely, the entire volume is inside the liquid. You will be using that volume. So it has nothing to do with floating part. If it is floating, this is the equation. So, what is upthrust? Submerged volume of the object into density of liquid into G. Next line, but if object is floating, then weight of the object should be equal to weight of displaced liquid. Weight of the object should be equal to weight of displaced liquid. So remember this difference. You can use this format always. You can use this only if object is floating. Now let's solve very elementary question first, just for practice. And let's see how many of you will answer this. Look here, we have a cube of side length L. It's a cube, not a square. Remember, it's a cube, three-dimensional body. And density of this cube is rho by 2. And this is submerged in a liquid of density rho. Then what height of the cube is inside the liquid? A cube of density rho by 2 is floating. Well, if density is rho by 2, you know that it can only float. So, what is the height? What is the height which is inside the liquid? Answer this part fast. Should not take more than 10 seconds. Some of you are asking few doubts. The first one is asking, sir, is volume of displaced liquid equal to volume of body? You just think about it. The first doubt which is being asked is volume of displaced liquid equal to volume of the body? No, it cannot be. It cannot be. If you say this much body is submerged, then only this much water or liquid will be displaced. If you submerge the entire body, then only entire volume will be displaced. If you go inside a swimming pool and you are half only inside, then can you say that your entire body, volume of the entire body, you have displaced that much water? No, you have not. So the first doubt is, I hope, clear. The second doubt is, but if object sinks, h will be greater than the height of object. This is a good doubt and we'll discuss this later. The doubt is that if the whole thing sinks down completely, then this h will be greater than the height of the object. But good, still you will get the same thing. How? We'll see that part later on. Well, so far only one answer, and I'm looking for height, and therefore correct your answer, although it's almost correct. So the question is, you have an object which is floating. If object is floating, then this is the equation. What is mass? Volume. What is volume? L cube into G. This is the left hand side. What is mass of this cube? Volume, which is L cube, and multiplied by density, which is rho by 2. This is the n part, volume of the object, L cube, multiplied by its density, which is rho by 2 into G. Weight of displaced liquid. I hope it will be clear if I draw something like this. Any doubt regarding submerged volume will be clear in this case. Suppose you take this cube out and somehow you ask the liquid to freeze, to remain like this only. The walls, they do not collapse. Then what you have done? You have basically removed this much liquid shown in blue. I hope you can see this blue part. This much liquid was present at this place. You came, took this blue part out, and you have put in this object inside here, giving you this setup. So this is your displaced volume. But the way you remember everything is what? Weight of displaced object, displaced liquid is what? Base A, height h, into density. Which density? Density of the liquid, into G. Object, liquid. This side is for object, this side is for the liquid. What is A? L square. It's a cube, and therefore base area will be what? L square. Everything cancel. and you get H as what? L by 2. You can answer the question in just 10 seconds. Note down this. And only one person could answer this. Now all others, is it clear to you now? Yes or no? Now, let me answer the second doubt, because things will be clear and it will be easier for you to understand the whole thing. Understanding the concept of upthrust will be easier for you. And we'll take a very easy example so that everything is clear. Let's take a cube only. Suppose somebody has submerged the entire cube. Side length is L. It can be any shape. Remember, it can be any shape, any cylinder, sphere, cone. Concept will be valid. And with cone it is much easier to understand, and therefore pay attention to this. The first thing the doubt came was, if the entire cube is submerged, then what is the upthrust? And the very first doubt was that this height is much larger than the side length L. Let it be. Let's call it H2. Let's call it H1. Forget about the side forces. Can you see that there are two forces acting on the body? One is down thrust and the other is up thrust. All the liquid on top of it is going to push it down. Let's say this is F1, and all the liquid at the bottom is pushing it up. The force is F2. Remember, all the forces are what? Normal reaction forces. Normal reaction acts towards the body. So, at the bottom, due to the pressure, there is an upward force F2. At the top, all the liquid present is pushing it down. This is force F1. What is F1? Pressure into area. What is P1? H1 rho G. What is pressure at this place? Pressure at this place is this height multiplied by rho and G. That's your F1 part into A. Now let's talk about F2. F2 will be P2 multiplied by A. What is P2? Pressure at this place. What is height of this particular level. So, what is the height of this particular level from the top, H2? What is the pressure? H rho G multiplied by A. That's your F2. Remember, pressure at a given level is present in all the directions. At this place, the pressure is pushing it down. At this place, pressure is pushing it up. So what is net force? F total. F total is F2 minus F1. Which one is larger force? F2. What is this coming? H2 minus H1 into A into rho G. What is H2 minus H1? H2 minus H1 is what? L into A multiplied by rho G. What is L into A? Submerged volume. So it doesn't matter if some liquid is present on the top portion. Ultimately, when you find your F total, this F total will be always in the form of upthrust. And in upthrust, we have a direct result now. Go for what? Volume of submerged object. Find out this much volume. If it's completely submerged, find out the total volume. If it's partially submerged, find that volume which is inside the liquid. In every situation whatsoever, upthrust will be V into A. This H2 minus H1 into A. H2 is this and H1 is this. If it's a cube, it will give you L. If it's a cylinder, it will give you the length of the cylinder. But ultimately, आपके काम क्या चीज आने वाली है? This part. Now, although only one person asked this much, but are you all comfortable with this part, that the submerged portion and all these things? Are you comfortable with this? Yes or no? Good. Note down this fast. Look at this interesting question. There are two liquids of density rho and 3 rho. And the object, which is a cube, its density is what? 2 rho. So the first thing which is clear is what? Since it's denser than the first liquid, it will be definitely inside. And it's lighter than the 3 rho liquid, and therefore it is floating in 3 rho. The question is that what part of it lies inside the liquid 3 rho? It's a cube. Now I'll give you about 30-40 seconds. Let's see how many of you can answer this. And believe me, you can answer the question in just one line. So this is the hint. Rho, 2 rho, 3 rho. It's a cube of side length L. You need to find H, which lies inside this 3 rho. Let's see, give it a try. There's only one answer. Look here. Long method. First, just to understand basics. And if you are interested, solve every equation given in this first long method. This is basically for as a homework. What is the homework part? A down thrust is coming from the first liquid. The first liquid is giving it these forces. Sideways, which will cancel each other, and a down thrust. The liquid 3 rho, this 3 rho liquid is giving it these type of forces shown in red. They will cancel each other. Find this. Call this F2. Call this F1, F2 and F1. F2 will be balancing mg and F1. This is your first long method. लेकिन आइडिया होना चाहिए, इसलिए इस मेथड को भी दिमाग में रखना. फिर से सुनना क्या हुआ यहाँ पर. You have a cube and the liquid on the top, rho, it is only giving it a down thrust. The place where a first liquid is in contact with the object is top surface, and at top surface, if I ask you to draw a free body diagram using normal reaction, you can only have what? Towards the body. That is your F1. The liquid at the bottom, what is the normal reaction coming from this? Towards the body, and that normal reaction is F2. Normal reaction mg, balance because it's floating, and you find that F2 is equal to mg plus F1. F2 and F1, these are not upthrust forces. Remember in this form that these are normal reaction forces or contact forces. These are normal reaction or contact forces. This is your first method. Those of you who are interested in basics, try this and you will get the answer. Look at the second method, much easier one. Second method क्या बोलता है? Second method ने बोला ऑब्जेक्ट फ्लोट कर रहा है. Yes, good. एक तरफ क्या कर दो बॉडी का वेट. What is the body weight? mg. We'll find that. दूसरी तरफ क्या होना चाहिए? दूसरी तरफ होना चाहिए Fu1, Fu2. Upthrust. Now, if you look at this basic figure, then definitely first liquid is pushing this object down, but अपने को बताइए कि अगर ऑब्जेक्ट लिक्विड के अंदर है तो अल्टीमेटली उस पर क्या लगता है? अपथ्रस्ट. And what is upthrust? Volume of object submerged inside the liquid. Base area is A. This is H. This will be what? L minus H. It's a cube. Height is what? L. This is H. Remaining is what? L minus H. What is Fu1? What is upthrust force? Volume of object submerged inside the liquid. How much portion or how much volume of the object is inside the first liquid? A multiplied by L minus H. Hopefully समझ में आ रहा होगा. केवल जो upper portion है इस object का is inside the first liquid. Volume submerged into density of liquid into G plus what is the upthrust coming from the second liquid? Volume of object submerged A into H. Base area A. What is the height inside the second liquid? H into density of liquid 3 rho multiplied by G is equal to what? M. Mass of the body. What is mass of the body? Its volume, which is A into L. What is the volume of the object? A into L. Density of the object. This is mass of the object. Density of the object into G. One line equation, solve it and you will get your answer. Now, इस method में क्या हो रहा है? आपको पता है कि fundamentally contact force wise this upper liquid is pushing it down, लेकिन इस लिक्विड का अल्टीमेटली इफेक्ट यहां भी ट्रांसफर होगा. तो जब मैं उस इफेक्ट को काउंट करूंगा तो आई कैन सिंपली से व्हाट, forget about the contact forces, use what? Upthrust. If you will try this, तब भी आंसर वही आएगा. थोड़ा मैं इसको बता दे रहा हूं, पता नहीं कितने लोग ट्राई करेंगे या नहीं. Suppose this much height is H1. This is H1. Then F1 is H1 rho G multiplied by A. This is H1. Now, note down this much, and if anyone can get me F2, note down everything, first method, second method shortcut, and instead of homework, if you can get me the value of F2, then write that down in the comment box. Let's see how many of you can. By the way, if you understand the difference between contact forces and Fu1 and Fu2. These are not contact forces, these are upthrust forces. Remember, U and U. Contact forces are normal reaction forces. Normal reaction force always acts towards body. If they ask you that what is the contact force on the object coming from the liquid on top, it's a downward force, but effectively it is going to give you Fu1, which will be clear once you answer F2. Wait, note down everything, try to answer F2, and once I answer this part, if you understand everything, once I answer F2 and you understand everything, you will be writing yes in the comment box. Not now. Let's see how many of you will answer F2. Now, Fu1, Fu2 got, these are the values for Fu1 and Fu2. Now look what's value of F2. And once I write F2 and you are comfortable with that, you will be writing yes in the comment box. If you need F2, you need to find pressure at this place. What is pressure at this place? How do you find pressure? P2. What is P2? H1 plus this is P2. If you understand this P2 first, write down yes in the comment box. P2, pressure at this place. Do you understand this equation? Look at this figure. Pressure at the bottom of the cube. Are you comfortable with this? Yes or no? Let's see, without my help, you understand this. Only one yes so far. Take your time. As and when you understand it, write down yes. I'm taking too long. Too long. इधर देखो यार, तो बहुत टाइम ले रहे हो भाई. इस ऑब्जेक्ट के ऊपर कितना लिक्विड था? H1. तो अगर आपको यहां प्रेशर चाहिए, आप क्या करते? आप ये पूरी की पूरी हाइट काउंट करते, इसका प्रेशर. सपोज आपसे किसी ने ये दिया होता कि भाई आपको दे रखा है किसी ने, there are two liquids of height h1 rho 1 h2 rho 2, सपोज ये क्वेश्चन होता, तो आपसे पूछा जाता भैया यहां पर क्या प्रेशर है, तो आप क्या बोलते हैं h1 rho 1 g। आपसे पूछा जाता है यहां पर क्या प्रेशर है, तो क्या आप केवल ये लिख देते h2 rho 2 g। भाई इसके ऊपर वाली बॉडी भी तो क्या लगाएगी, वेट। इट्स सिंपल लॉज ऑफ मोशन। एक ब्लॉक है 5 kg का, उसके ऊपर एक 4 kg और है, तो आपके हाथ को क्या संभालना है, केवल 5 kg नहीं, 5 and 4। What is the pressure at this place? h2 rho 2 g plus h1 rho 1 g। इस जगह पर कितना लिक्विड संभालना है, इस जगह को कितना संभालना है, दोनों दोनों। अल्टीमेटली क्या लिखा हुआ ये m2g प्लस m1g, दोनों का वेट डिवाइडेड बाय बेस एरिया। सो इस जगह पर कितना लिक्विड है इसके ऊपर, दिस मच रो। व्हाट इज दिस हाइट, this is h1, this is h1, and what is this top portion of the block? Top portion of the block is L minus H. So what is technically height of this liquid? H1 plus L minus H into rho G. अब जो सेकेंड लिक्विड था वो यहां तक कितना है, ओनली दिस मच प्रेशर अपने को यहां चाहिए ना, तो इस जगह के ऊपर सेकेंड लिक्विड कितना है, दिस। व्हाट इज दिस, H। व्हाट इज द लिक्विड, 3 rho into G। Now do you understand this P2 pressure at this place, yes or no? Good. So अब मैं इसी के अंदर ऐड कर दूंगा भाई। अपने को क्या चाहिए था, अपने को चाहिए था F2 force। What is force? Force is pressure multiplied by area। इस पूरी कहानी को किससे मल्टीप्लाई कर दो, A से। इतना सब कुछ दिस इज योर F1। F1 हमने नोट किया था थोड़ी देर पहले। What is F1? H1 rho G into A। Put these values in this equation, solve for H। लेकिन क्या क्या सोचना पड़ गया इतना कि भाई ये क्या है, ये क्या है, ये क्या है। Whereas the second method, it tells us what, on the right hand side use the weight of the object, which is mg. On the left hand side use upthrust. If an object is inside the liquid, ultimately it is getting what, upthrust. What is upthrust? Volume which is submerged inside the liquid. We have found the volume submerged inside. We have found the volume submerged inside. Put on this. One of you is saying that audio is not clear, voice is cracking. Is it with everyone? So then those who are finding that voice is cracking, do one thing, disconnect and reconnect, and maybe things will be better. Well, some of you are saying that there is some problem with the audio, but others are saying that audio is good. So those who find that there is some problem with the audio, do one thing, disconnect and reconnect. Answer this question. It's a very interesting one. There is an ice cube and it is floating. You have a beaker filled with water, and in that water you have an ice cube. Basically, ice is present and the ice is floating. Now, as ice melts, what happens to water level? It goes up or comes down? Write down the question. When ice floating in a beaker melts, what happens to water level inside? When ice floating melts, what happens to water level inside? Well, some of you have answered correctly. And the correct answer is that it remains unchanged. As ice melts, there will be no change in the water level. Understand this with the help of this logic and always remember the statement. Look, let's say this ice cube, this is an ice cube. And this is water. And this is the height of liquid water inside. Let's say capital H. The question is that when this ice melts, what happens? The answer is your H remains same. As a statement, you can remember this. H remains same. It's not going to change. Why? Look here, if you can understand this, again, your basics will become clear. Try to understand this. Without using much of these equations and all, we'll use simple figures. We can answer the question with the help of equations also, but it will be better if you develop this type of approach. And do tell me if you understand this or not. This is the same H. So the question is that you have an ice cube, a solid ice cube, and then it melts. When it melts, what you get? The final answer is that H remains same. Now let's prove it with the help of this technique. This portion in blue is displaced liquid. कब से है displaced? आपने क्या किया? थोड़ी देर पहले मैंने इस तरह की टेक्निक आपको यूज करवाई थी. हमने इस क्यूब को बाहर निकाला. Just imagine. इस क्यूब को बाहर निकाला एंड देन वही आपने वाटर को बोला freeze. Not that type of freeze. Freeze means freeze. Freeze in the action. So the walls, they do not collapse. The things which you see in black, if you can see the color, this part is that water which you find when cube is out. इसका मतलब क्या था कि ये जो ब्लू पोर्शन था यहां पर इतना लिक्विड प्रेजेंट था, वाटर वॉज प्रेजेंट. आप आए, आपके पास एक आइस क्यूब था, लेट्स स्टार्ट फ्रॉम दिस. हमने क्या किया, आइस क्यूब था, यहां पर अपने पास एक बीकर था और पूरा का पूरा लिक्विड एंड ऑल, वाटर एंड ऑल सब कुछ था उसमें. हमने क्या किया, ये ब्लू वाला लिक्विड हटा दिया, ब्लू वाटर हटा दिया. ब्लू इज वाटर. If you cannot see the color, remember this is water. Let's make it more blue, more blue. Maybe it is visible now. So the thing which you see in black is the ice cube, and the thing which you see in blue is the water. आपने क्या किया, आइस क्यूब को इसके अंदर रखना था, ब्लू साइड में, आइस अंदर, एंड यू गॉट दिस. And if you got this, then do you know that this and this, they have same weight. Weight of a floating object is equal to weight of displaced liquid. Now tell me fast, are you comfortable with this? इसके बाद आगे बढ़े अपन. दोनों का साइज अलग अलग है, दोनों का वॉल्यूम अलग अलग है, but they have same weight. Why? Because this ice cube, we have been told that, is floating in water, and we know that according to Archimedes, if something is floating, then weight of floating object should be equal to weight of displaced liquid. Are you comfortable with this part? Yes or no? Good. अब समझना, मैंने आपसे बोला कि एक काम करो कि भाई ये जितना पोर्शन था, ये कौन था? डिस्प्लेस्ड वाटर. डिस्प्लेस्ड वाटर. डिस्प्लेस्ड वाटर. अब देखना, इस आइस क्यूब का वेट और डिस्प्लेस्ड वाटर का वेट दोनों का क्या है? सेम. देन आपसे क्या बोला गया कि यार ये जो अपना बीकर है, इस बीकर को फिर से ड्रॉ किया हमने, आइस क्यूब को बाहर निकाला, आइस क्यूब को बाहर निकाला, और टेम्परेचर इंक्रीज किया. टेम्परेचर इंक्रीज करेंगे तो ये आइस क्या होगी? मेल्ट. एंड वंस इट मेल्ट्स, you get what? You get melt water. Water which you get after ice melts. Now, ice बाहर, water को बोला freeze. अब इस ice को हमने क्या किया? Melt किया. And then you get what? Melt water. Do you understand this? This blue melt water and this displaced melt water, they are same. Mass wise, weight wise, volume wise. Why? ये क्या है? आइस. अगर आपके पास मान लो 5 kg आइस है, तो 5 kg आइस को मेल्ट करोगे तो 10 kg वाटर थोड़ी मिलेगा. जितनी आइस है उतना ही क्या मिलेगा? वाटर. कंजर्वेशन ऑफ मास. तो ये जो आइस है, इसका मेल्ट होने के बाद जो वाटर बना, दोनों का वेट क्या है? सेम. व्हाट इज दिस? मेल्ट वाटर. बट यू ऑलरेडी नो दैट दिस आइस has same weight as of this displaced water. That means what? कि आपने displaced water को किसके बराबर प्रूव कर दिया? Melt water. Which means what? अब कहानी क्या आई? आइस बाहर निकाल, मेल्ट कर, क्या बना? मेल्ट वाटर. ये मेल्ट वाटर क्या है? डिस्प्लेस्ड वाटर. डिस्प्लेस कहां से किया था? यहां से. तो अगर मैंने यहां से इतना पीस निकाला है और फिर इसको इसी में डाल दिया है, मैंने यहां से डिस्प्लेस किया, आइस को डाला, आइस का साइज ज्यादा है, आइस को मेल्ट किया, ये मिला. लेकिन ये क्या है? वही जो डिस्प्लेस वाटर था, तो जिसे निकाला उसी को फिट कर दिया अगर, तो क्या आपकी हाइट चेंज होगी? आंसर इज नो, एंड देयरफॉर h will remain what? Same. Do you understand this? Yes or no? And try to develop this type of approach. कहने के लिए we are using an equation like this, but पूरी कहानी केवल क्या है? Weight of the object, floating object, is equal to what? Weight of displaced liquid, and weight of the object once it melts is equal to melt water, and therefore your h will remain what? Same. Now, there are few interesting homeworks. Those of you who are interested, try those things. Write down those homeworks. We have an ice cube. If you want to take a screenshot of this, take the screenshot fast. The question is that, is this possible to immerse ice in water? Is it that we are throwing ice in water? Well, I don't understand your question. The question is not clear. I'll send you the recording, listen again everything, and you'll understand. It's not a difficult thing. Very elementary, very easy. And if you try these homeworks, थोड़ी और अकल आएगी आपको. So now look at the question. There are two homeworks. First one, in this ice cube we have a wooden piece. Inside the ice there was a wooden piece. Wood means something which after ice melts is going to float. So ice cube has a wooden piece inside, ice melts, what happens to H? First question. Write down this. Inside the ice cube, there is a piece of wood. What happens to water level when ice melts? This is first part. In the second part, this is a steel ball. Steel. Now when steel melts, when ice melts, what happens to water level? This is your second homework. What is different between these two homeworks? When ice melts, wood, it's going to float. It's lighter than water. When ice melts, the steel ball inside is not going to float. It will simply sink down. That will decide what happens to H. This is the hint. Note down these two questions and then you can leave. Thank you very much.